NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. In this video, we'll solve an exponential equation step by step. Let's look at the example. Let's start by applying the laws of exponents to simplify the equation. First, we'll rewrite the terms using the law of exponents that states a to the power of m times a to the power of n equals a to the power of m plus n. So we'll rewrite 5 to the power of 3x plus 2 as 5 to the power of 3x times 5 to the power of 2. Similarly, 5 to the power of 3x plus 1 becomes 5 to the power of 3x times 5 to the power of 1. In the denominator, 9 to the power x plus 1 becomes 9 to the power x times 9 to the power 1. Now, let's simplify further. We know that 5 squared equals 25, and 5 to the power of 1 is just 5. So in the numerator, we can factor out the common term 5 to the power of 3x, giving us 5 to the power of 3x multiplied by the difference of 25 and 5, which is 20. In the denominator, 9 to the power 1 equals 9. So we have 9 to the power x times 9 plus 9 to the power x. We can factor out the common term 9 to the power x, giving us 9 to the power x multiplied by the sum of 9 and 1, which is 10. Let's continue our simplification. We know that 25 minus 5 equals 20, and 9 plus 1 equals 10. So our equation becomes 20 times 5 to the power of 3x divided by 10 times 9 to the power of x equals 250 divided by 9. Now we can simplify the constant terms in our fraction. We can divide both 20 and 10 by their greatest common divisor, which is 10, giving us 2 and 1. So our equation becomes 2 times 5 to the power of 3x divided by 9 to the power of x equals 250 divided by 9. To isolate the exponential terms, we'll move the constant 2 to the right side of the equation. Dividing both sides by 2, we get 5 to the power of 3x divided by 9 to the power of x equals 250 divided by 2 times 9. Let's calculate 250 divided by 2 times 9. 250 divided by 2 equals 125. So we have 5 to the power of 3x divided by 9 to the power of x equals 125 divided by 9. Now, let's use the fact that 5 cubed equals 125. So 5 to the power of 3x can be rewritten as 5 cubed to the power of x, which is 125 to the power of x. Our equation becomes 125 to the power of x divided by 9 to the power of x equals 125 divided by 9. Using the law of exponents, we can rewrite the fraction as 125 divided by 9 all to the power of x. So we have 125 divided by 9 to the power of x equals 125 divided by 9. Now, we can observe that if we raise a number to a power and the result equals the original number, then the exponent must be 1. So 125 divided by 9 to the power of x equals 125 divided by 9 to the power of 1. Therefore, x equals 1. Let's look at our example. We need to solve the following exponential equation. The fraction, open parenthesis 0.25 close parenthesis raised to the power of 1 minus x times 80 raised to the power of negative x divided by open parenthesis 0.1 close parenthesis raised to the power of x plus 2 times open parenthesis 0.2 close parenthesis raised to the power of negative 2 equals 1. Let's solve this step by step, following a structured approach where we'll rewrite this equation by converting decimals to fractions and then using the properties of exponents. First, let's rewrite our equation by converting the decimals to fractions and simplifying where possible. We'll convert 0.25 to 1/4 and 80 to 10 times 8. The numerator becomes open parenthesis 1/4 close parenthesis raised to the power of 1 minus x times open parenthesis 10 times 8 close parenthesis raised to the power of negative x. The denominator stays as open parenthesis 1/10 close parenthesis raised to the power of x plus 2 times open parenthesis 2/10 close parenthesis raised to the power of negative 2. Next, let's convert the remaining decimals in the denominator to fractions. We'll convert 0.1 to 1/10 and 0.2 to 1/5. So the denominator becomes open parenthesis 1/10 close parenthesis raised to the power of x plus 2 times open parenthesis 1/5 close parenthesis raised to the power of negative 2. Now, Let's express all terms using the prime factorization and powers. We know that 1/4 equals 2 to the power of negative 2, since 1/4 equals 1 over 2 squared. 8 equals 2 cubed, and we'll keep 10 as is. The denominator becomes open parenthesis 10 to the power of negative 1 close parenthesis raised to the power of x plus 2 times open parenthesis 5 to the power of negative 1 close parenthesis raised to the power of negative 2. Let's use the laws of exponents to expand and simplify. Using the rule that open parenthesis a to the power of m close parenthesis raised to the power of n equals a to the power of m times n, the term open parenthesis 2 to the power of negative 2 close parenthesis raised to the power of 1 minus x becomes 2 to the power of negative 2 times 1 minus x, which equals 2 to the power of negative 2 plus 2x. 8 to the power of negative x becomes 2 cubed to the power of negative x, which equals 2 to the power of 3 times negative x, or 2 to the power of negative 3x. The denominator, open parenthesis 10 to the power of negative 1 close parenthesis raised to the power of x plus 2, becomes 10 to the power of negative x minus 2, and open parenthesis 5 to the power of negative 1 close parenthesis raised to the power of negative 2 becomes 5 to the power of positive 2. Now, let's combine like terms in the numerator. In the numerator, we combine 2 to the power of negative 2 plus 2x and 2 to the power of negative 3x to get 2 to the power of negative 2 minus x. In the denominator, we have 10 to the power of negative x minus 2 and 5 squared. Remember that 5 squared equals 25, so we'll move this to the right-hand side of the equation. Next, we'll simplify the exponential terms with base 10. Since we have 10 to the power of negative x in the numerator and 10 to the power of negative x minus 2 in the denominator, we can divide them. 10 to the power of negative x divided by 10 to the power of negative x minus 2 equals 10 to the power of negative x minus open parenthesis, negative x minus 2 close parenthesis. This gives us 10 to the power of negative x plus 2, which simplifies to 10 squared, or 100. So now we have 2 to the power of negative 2 minus x divided by 100th equals 25. Now, let's express the denominator term as a fraction and multiply both sides. 10 to the power of negative 2 is 100th, so we have 2 to the power of negative 2 minus x equals 25 times 100th. Let's simplify the right-hand side of the equation. 25 times 100th equals 25 over 100, which is 1/4. Now let's express 1/4 as a power of 2. 1/4 equals 1 over 2 squared, which is 2 to the power of negative 2. Since the bases are the same, we can set the exponents equal. This gives us negative 2 minus x equals negative 2. Let's solve for x by adding 2 to both sides. This gives us negative x equals 0. Finally, multiplying both sides by negative 1, we get our answer. X equals 0. Let's start solving this step by step. First, I'll rewrite the equation using powers of 2 to make it easier to work with. 8 can be rewritten as 2 to the power of 3. So 8 to the power of 1 minus x becomes 2 to the power of 3 to the power of 1 minus x. Similarly, 16 is 2 to the power of 4. So 16 cubed becomes 2 to the power of 4 cubed. We also need to rewrite 1/4 as 1 over 2 squared. And finally, 0.25 can be written as 25 over 100. Next, I'll apply the power rule for exponents, which states that the power of a power equals the product of powers. So 2 to the power of 3 to the power of 1 minus x becomes 2 to the power of 3 times 1 minus x, which simplifies to 2 to the power of 3 minus 3x. Similarly, for the other terms, I'll expand all the exponents and simplify where possible. Now, I'll continue to simplify the expression. In the denominator, I'll apply the power rule again to expand 2 to the power of negative 2 to the power of x minus 2. This becomes 2 to the power of negative 2 multiplied by x minus 2, which gives us 2 to the power of negative 2x plus 4. Now, I'll combine like terms in the numerator. 2 to the power of 3 minus 3x times 2 to the power of 4x equals 2 to the power of 3 minus 3x plus 4x, which simplifies to 2 to the power of 3 plus x. In the numerator, 3 minus 3x plus 4x simplifies to 3 plus x. In the denominator, negative 2x plus 4 plus 12 equals negative 2x plus 16. Next, I'll use the law of exponents that states a to the power of m divided by a to the power of n equals a to the power of m minus n. So I can rewrite this fraction as 2 to the power of 3 plus x, this fraction as 2 to the power of 3 plus x minus the quantity negative 2x plus 16. Let's simplify the exponent on the left side. 3 plus x minus negative 2x plus 16 equals 3 plus x plus 2x minus 16, which is 3 plus 3x minus 16. Meanwhile, on the right side, the negative exponent of negative 1 means we take the reciprocal of 2 to the power of negative 2, which gives us 2 squared. Let's simplify the exponent on the left side further. 3 plus 3x minus 16 equals negative 13 plus 3x. When two powers with the same base are equal, their exponents must be equal. Therefore, negative 13 plus 3x equals 2. Now I'll solve for x by adding 13 to both sides of the equation. This gives us 3x equals 2 plus 13. 2 plus 13 equals 15, so 3x equals 15. Finally, dividing both sides by 3, we get x equals 15. Finally, dividing both sides by 3, we get x equals 5. Therefore, the solution to our exponential equation is x equals 5. Let's quickly verify. Let's solve an exponential equation. First, let's rewrite 0.2 as a fraction. 0.2 equals 2 divided by 10. Now, we can simplify the fraction 2/10 to 1/5 by dividing both numerator and denominator by 2. 1/5 can be written as 5 to the power of negative 1. When we raise a power to another power, we multiply the exponents. So 5 to the negative 1 raised to the power of x minus 14 equals 5 to the power of negative 1 times x minus 14, which simplifies to 5 to the power of 14 minus x. Since the bases are the same on both sides of the equation, the exponents must be equal. Let's solve for x by first adding x to both sides of the equation. On the left side, negative x plus x equals 0, leaving us with 14. On the right side, we combine like terms. 6x plus x equals 7x. Finally, we divide both sides by 7 to isolate x. Therefore, x equals 2. Let's look at an example. We need to solve the exponential equation 5 to the power of x plus 2 minus 5 to the power of x equals 600. Let's start by breaking down the first term. 5 to the power of x plus 2 can be rewritten as 5 to the power of x times 5 squared. This gives us 5 to the power of x times 25 minus 5 to the power of x equals 600. Now, let's factor out the common term 5 to the power of x. We get 5 to the power of x times open parenthesis 5 squared minus 1 close parenthesis equals 600. Let's simplify what's inside the parentheses. 5 squared is 25, so we have 5 to the power of x times 24 equals 600. Now, let's isolate the term with the variable. We divide both sides by 24. This gives us 5 to the power of x equals 600 divided by 24. Let's simplify the right side. 600 divided by 24 is 25. So 5 to the power of x equals 25. We can write 25 as a power of 5. 25 is 5 squared. So 5 to the power of x equals 5 squared. Now, we can apply our rule. When the bases are equal, the exponents must be equal. Since both sides have the base 5, we have x equals 2. Our example problem is to solve the following exponential equation: 125 to the power of x minus 1 plus 625 to the power of x, all divided by 5 to the power of 3x equals 6 over 5 cubed. Let's start by rewriting 125 and 625 in terms of powers of 5. We can write 125 as 5 cubed and 625 as 5 to the 4th power. Now we can use the power rule for exponents, which states that when we have a power raised to another power, we multiply the exponents. So 5 cubed to the power of x minus 1 becomes 5 to the power of 3 times x minus 1, or 5 to the power of 3x minus 3. Similarly, 5 to the 4th power to the power of x becomes 5 to the power of 4x. Now, let's factor out 5 to the power of 3x from the numerator and denominator. This gives us 5 to the power of 3x multiplied by 5 to the power of negative 3 plus 5 to the power of x, all divided by 5 to the power of 3x. We can now cancel the common factor of 5 to the power of 3x in the numerator and denominator, leaving us with 5 to the power of negative 3 plus 5 to the power of x equals 6 over 5 cubed. Next, let's multiply both sides by 5 cubed to eliminate the fraction on the right side and simplify the left side. Now, let's distribute 5 cubed inside the parentheses. 5 cubed times 5 to the power of negative 3 gives us 5 to the power of 0, which equals 1. And 5 cubed times 5 to the power of x gives us 5 to the power of x plus 3. Remember that any number raised to the power of 0 equals 1. So 5 to the power of 0 equals 1. So our equation is now 1 plus 5 to the power of x plus 3 equals 6. Now let's isolate the exponential term by subtracting 1 from both sides. When we have the same base on both sides of an equation, we can equate the exponents. So x plus 3 equals 1. Finally, let's solve for x by subtracting 3 from both sides. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.